test to review for 9. What is the perimeter of a polygon with the vertices A, B, and C? Round your answer to the nearest whole number. You could just draw a sketch for the coordinate points, but since I have graph paper, I'm going to use that. So we got the point 3, 5, and then 6, 1, and 6, 5. And we want the perimeter of this polygon, also a triangle. And this side length here is 3 squares. Here we've got 4. And we need this other side so that we can add up the 3 and the 4 and the side that we don't know right now, and that will be our perimeter. So we know the perimeter is bigger than 7 because 3 and 4 is 7, and we need more than that. So we're going to use, since this is a 90-degree angle right here, we can use a squared plus b squared equals c squared, Pythagorean theorem. And it doesn't matter what's A and B, but it definitely matters that this side opposite of the 90, or the longest side, is C, or the unknown side. So with this one, I'm going to put 3 in for A and 4 in for B, and equal to C squared. So we got 9 plus 16 equals C squared. This is 25. And if I want C to be alone, right now there's a square on it. To undo squaring, we square root both sides. The square root of 25 is positive or negative 5. But because we're talking about a side length, it's just a positive 5. So it's 3 plus 4 plus 5 for the perimeter. And 3 plus 4 is 7, plus 5 more is 12. So it's 12 units for the perimeter of that triangle. So here we know our answer is 12 units. Write an equation in slope-intercept form. Remember, that's y equals mx plus b of a line that is parallel to y equals 1/3 x plus 9. Parallel means that the rise and run, right? 1/3 x plus 9, I'd go up to 9 and go up 1/3. It would look like this, close to it. If I want parallel, remember that means I need that same slope. But it doesn't matter what the y-intercept point is. As long as that slope's the same, those lines are all going to be parallel. So I need y equals 1/3 x. I could just leave it like that and have it go through 0. I could do y equals 1/3 x minus 2. Y equals 1/3 x plus 1. Y equals 1/3 x minus 1. You could have lots and lots of different answers, but you have to have that 1/3 x in it for the lines to be parallel. Number 3, write an equation in slope-intercept form, same form as before, of a line that is perpendicular. Remember, that's 90 degrees. Okay, 90 degrees, y equals negative 4x minus 1. So if we were to look at a quick sketch of that, that would look something like that. Line y equals negative 4x minus 1. If I want perpendicular to this, I need it to be 90-degree angle to that. So it doesn't matter where the line is, but this right here has to be a 90-degree angle. And the way that we get a 90 is the slope If that's negative 4x, notice it has to go the opposite direction. So our slope has to be a positive number, and in this case it's not going to be up 4 over 1. We need to flip that slope around, so it's going to be that reciprocal. It's going to be 1/4. And as long as we use that 1/4, we can go through any y-intercept we want as long as the slope is a positive 1/4. So y equals 1/4 x minus 2, y equals 1/4 x plus 3, y equals 1/4 x minus 5, y equals 1/4 x, right? It could just go right through the center, right through 0, 0. So any of those work as long as you have that 1/4 x positive. Write an equation in standard form. Remember, this is ax plus by equals c. So it's not the same as what we were doing, just barely. A little bit different. Of a line that's parallel to y equals 1/4 x minus, or y equals 3/4 x minus 4. So in this case, as long as we have that 3/4 x, we know it's going to be parallel. And I'm going to put plus 1 right here, because as long as that slope's the same and the y-intercept is different, we're going to have a parallel line. So in this one, we need standard form. And the way to get this into standard form is, the easiest way is to get rid of that 4 on the bottom of that fraction first. So to get rid of that, I'm going to times everything by 4. And we'll see why this helps make it look like that in standard form. So 4 times y is 4y. 3/4 times 4 is just 3x. And then positive 1 plus 1 times 4 is just 4 now. Okay, so we're getting closer to this. And all I want to do now is move the x. Notice that the x's and the y's have to be on the same side. So I'm going to move the x's over. I want to get rid of all of them, so I'm going to minus 3x. And I want the x's first, so I'm going to do negative 3x plus 4y equals 4. Now there are some people that say that you have to have that a number be positive, and notice our a number is negative. So a quick and easy way to get rid of that, remember how we changed signs when we were doing systems? That's the same thing as taking this whole thing and just multiplying by a negative 1. So if we do that, we'd end up with a positive 3x, a negative 4y, and a negative 4. And that is a positive a number there. So we got ax by equals c. And that's what we want for standard form. Okay, determine whether the lines 4x minus 5y equals 15 and the other one are parallel, perpendicular, or neither. The easiest way to do this is to actually solve these for y so that we know what the slope is. So we're going to get y alone, move our x's over. Negative 5y is negative 4x plus 15. I did put the x's first. Again, you could have written that. I could have written negative 5y equals 15 minus 4x, and that's okay too, right? I just switched them. Just doesn't make a difference as long as the signs are the same in front of each one. So here I need to get rid of the negative 5. I divide it out. divide out -5. So this is y equals, I'd get -3, and -4/5 just reduces to a +4/5x. And you could type that in your calculator. So this would be the same thing, just a +4/5x minus 3. It doesn't matter which way you write it. So the second one here, we're going to add the 5x over. I'll just leave it the way that it's written. Put the 22 plus 5x first. And then divide it by the 4. So we got y equals 22/4 reduces to 11/2. And 5/4 just is a positive still, 5/4. So positive 5/4, positive 4/5, that's what we're comparing, those slopes, to check to see whether it's parallel, perpendicular, or neither. And because those slopes are both positive, I'm not going to have this 90-degree angle up here that I need. Those lines need to be going in different directions. So I have to have different signs, and the fraction is flipped. All I have right now is a flipped fraction, so that's not going to be perpendicular. Parallel, they have to be exactly the same, so it's not parallel. So for this number 5, we know that those two equations are neither parallel or perpendicular, so it's neither. Number 6, write an equation in slope-intercept form of a line that passes through -2, 7 and is perpendicular. I like to highlight that word so I remember. And it passes through that point right there. To y equals -1/4 x plus 1. Remember, perpendicular, so for this, if I want perpendicular, I'd go through 1, I'd go down 1/4, and it looks something like that. If I want perpendicular, I need it to be going 90 degrees. I know that doesn't quite look 90, but it needs to be going the opposite way, so it needs to be positive, and the fraction flips over. So my perpendicular slope is going to be +4/1, which is just 4. So that's my slope, perpendicular. And I need it to go through that specific point. So that point needs to be a solution to the equation that I write out. So to make that happen, I'm going to write y equals mx plus b. Notice it does say slope-intercept form. That's what we just wrote out, y equals mx plus b. The y value, the 7 has to work. The slope has to be a 4. And the -2 is my x value. So I'm going to find where does it cross through the y-axis. That's the b value. So -4 times, or 4 times -2 is -8, is 7. I get the b alone, so I'll add the 8 over. And the b is 15. So for this one, my equation is going to be y equals 4x. Again, this is the perpendicular equation. 4x that has plus 15 as the y-intercept. So if I were to graph that, my line is somewhere going through up here with that up 4/1, and that line is perpendicular, and it goes through the point -2, 7, wherever that might be on that graph. So it's just a sketch of it. Number 7, write an equation, slope-intercept form of a line that passes through that's parallel, y equals 1/2 x minus 3, and passes through this point, xy. So same idea. We know that on this one, we're going to have a slope that's the same because it's parallel.